Today, we're diving into the fascinating world of paper making. We'll be taking you through the captivating process of transforming raw materials into the sheets that we write, draw, and create on. So grab your curiosity and let's dive into the enchanting art of paper making together. The paper-making process in an integrated pulp and paper mill commences in the Woodyard here at Pixel's Specialty Solutions. Here the wood is received, debarked, chipped, and screened. The mill receives wood in two forms: logs, also known as round wood, and pre-cut chips. Upon unloading, all round wood is sorted into softwood and hardwood piles for later fiber isolation during the pulping process. Pine and spruce trees, which have needles, are grouped in the softwood pile, while hardwood trees like oak, maple, and ash with leaves are stacked in a separate section. The journey of round wood commences as it enters a lengthy conveyor belt, gradually advancing towards the debarking drum. Once inside the drum, the logs intertwine and roll, resulting in the stripping of their bark. The drum contains openings for the bark to fall through, allowing it to be collected and used as an eco-friendly biofuel. The logs are seamlessly transported and processed through an industrial chipper, swiftly transforming them into perfectly sized 1 inch by 1 inch square chips within a matter of seconds. To ensure a high yield and quality of wood fiber during the pulping process, chips undergo a screening process. This removes any chips that are not of uniform size. It is crucial for the chips to have a consistent size as it enhances their efficiency in producing wood fiber. By eliminating irregularly sized chips, the screening process ensures that the pulping process yields optimal results. During the screening process, small chips and sawdust are separated and sent to a power boiler along with bark from the debarking drum. These materials are then utilized as biofuel to produce clean burn electricity for both the mill and local residential houses. Interestingly, 40% of the mill's electricity needs are fulfilled through the sustainable energy source. To meet the growing demand for wood, trucks deliver pre-cut chips directly to the screening process, bypassing the Woodyard operation. By doing so, these chips can effectively help supplement the wood supply. Trucks are tilted at a 60-degree angle at this location to speed up the unloading process. After being screened, the chips are kept separate and then moved into piles of hardwood and softwood. These piles serve as waiting areas before the chips are processed for pulping. In the pulping process, wood chips are placed onto a conveyor belt and transported to a batch or continuous digester within the system. Both the chips and white liquor are introduced at the top of the digester to initiate the process of pulping. As the mixture descends, the liquor is heated to a temperature of 170 degrees Celsius, initiating the cooking process. The intense pressure and heat cause the white liquor to dissolve and digest the lignin, which binds the cellulose fibers. After several hours, this process is complete. The outcome is a collection of fibers known as pulp. The pulp, along with used cooking chemicals known as black liquor, is sent to the washing and screening section. This allows for the removal of black liquor and undigested wood, like nuts, from the pulp. During this stage, the pulp undergoes another important step called oxygen delignification. This process involves the use of oxygen, white liquor, and steam to eliminate any residual lignin and extract certain pigments from the pulp. The aim is to minimize the requirement of chemicals during the bleaching process. After pulp enters the bleaching area, it undergoes a series of stages to make it brighter. These stages help to transform the fibers from their initial brown color, known as brown stocks, to a pristine white. Nowadays, the majority of US mills opt for elemental chlorine-free or ECF chemicals for bleaching, which is a more environmentally friendly approach. If bleaching was not used, printing and writing papers would resemble a brown grocery shopping bag and certainly wouldn't be suitable in books, business forms, envelopes, and other types of printing papers. All the fibers have been prepared and are now in a suitable state for paper production. Up until this point, the production process has been focused on producing the pulp needed to make paper. After preparing the pulp, we proceed to enhance its quality, then mix in the fillers and dyes and pass the mixture through the paper machine. The paper machine resembles a massive dryer that removes water from the mixture, ultimately yielding a dry paper sheet. In its basic state, this paper machine serves the purpose of extracting water from the mixture to create the desired outcome. Paper machines are available in various sizes, ranging from the size of a bowling alley to 4 football fields. These machines are capable of transporting paper at astounding speeds of over 5,000 feet per minute, which is equivalent to approximately 60 miles per hour. At the beginning of our paper making process, we start by refining the pulp. This involves shortening and fraying the pulp fibers to increase contact points, making it easier for them to connect and intertwine. Since softwood fibers are naturally long, they have more contact points, which enhance the intertwining process. Hardwood fibers, on the other hand, have short lengths, which enable them to tightly pack together, resulting in bulk, smoothness, and opacity. By blending these fibers in specific ratios, it becomes possible to create papers with diverse physical qualities. This is the main reason that soft woods and hardwoods have been isolated throughout the entire process. Hardwood and softwood fibers are combined for the first time in a blend chest. This is where they are thoroughly mixed with fillers like clay, calcium carbonate, and titanium dioxide, which enhance surface and optical properties. Additional chemicals like silicon may also be included. This process ensures a harmonious blend of the fibers and other components, resulting in an improved overall quality of the material. The combination of fiber and additives is referred to as the furnish. It is mixed together and then travels from the blend chest to the head box. From there, the furnish moves onto a wire mesh known as the four-drainier section. As the furnish comes into contact with the wire mesh, it is approximately 99.5% water and 0.5% fiber, filler, and additives. As the mixture moves over the rotating mesh, gravity causes the water to drain away. To further reduce water content, enhance fiber formation, and prevent two-sidedness, a top wire former is employed to extract water from above the mesh. Upon reaching the end of the four-drainier, the interwoven fibers proceed to encounter the couch roll, another dewatering device. Then for the very first time, they uplift and transform into a cohesive sheet of paper. At this stage, the freshly created paper retains a water content of approximately 85%. In the press section, the soaked paper progresses through several rollers and felts, reducing the moisture content to about 65%. Afterward, it goes through a line of steam-filled dryer cans, where the heat from the steam eliminates more water. This process ultimately achieves a final moisture profile of about 4 to 5% water. Throughout the process, as the paper passes through the size press, starch is applied. This serves the purpose of filling microscopic ridges in the paper and creating a smoother surface. The result is improved credibility for fine printing and writing papers. Towards the end of the machine, the paper passes through high-tech scanners that look for variations in face's weight, moisture, caliper, opacity, brightness, and physical defects like in-holes. The scanning system's precision is such that it can detect a minuscule pin-sized hole amidst a 300-inch wide paper web moving at 40 miles per hour. Additionally, it can identify the precise position of the hole within the final roll, so it can be removed. Once the paper nears the end of the machine, it is tightly wound onto an enormous steel spool, which can hold an impressive weight of over 15 tons. When the spool reaches its maximum capacity, the paper roll is then sliced into smaller sections and rewrapped onto sturdy cardboard cores. These resulting rolls, also known as log rolls or jumbo rolls, provide a convenient way to handle the paper. This way it can be transported more easily to the wrapping station or to other locations in the mill for further processing. The paper in the finishing area undergoes preparation based on customer requirements, then is appropriately packaged and shipped. Once the finished rolls are produced by the paper machine, they are sent to a packing station. At this station, the rolls are carefully wrapped with either a watertight poly wrap or a craft wrap that is resistant to moisture. The craft wrapping station employs rollers that spin the paper and smoothly apply the wrap. To ensure neatness, fluted cardboard covers are positioned on both sides of the roll. As the rollers spin, the edges of the wrap are neatly folded and adhesive glue is applied for a secure hold. Thin cardboard caps called end caps are carefully pressed onto both sides using heated steel plates. The roll receives a finished label and is ready for transport to the customer. Customers who need sheeted product can rely on the ability to convert rolls into various sizes. Here they offer white, canary, and pink carbonless rolls. When unwound, the paper goes through the sheeter where a rotating blade cuts and stacks them into reams. The reams take a journey across conveyor belts where they receive a moisture-resistant wrap and product label. Finished reams are then packaged into cartons and shipped to the customer. In the shipping department, rolls are carefully loaded onto trailers using a specialized clamp truck capable of grabbing, lifting, and if necessary, rotating rolls without damaging the paper. To help improve visibility and increase safety, all clamp trucks are affixed with blue lights that can easily be seen around corners and in high traffic areas to help improve on-time delivery. Thank you so much for joining me on this fascinating journey through the paper production process. I hope you found it interesting. From harvesting trees to transforming them into sheets of paper, it's incredible to see how this everyday material comes to life. Remember, every time you hold a piece of paper, you're holding a masterpiece of nature and human ingenuity. If you want to dive deeper into the world of paper or explore more captivating topics, be sure to hit that subscribe button and join me on my future adventures. Until next time, stay curious and keep exploring.